Today we shall be considering a topic called sound wave. What is sound wave? Let's dive in. Okay. Sound waves are produced by vibrating objects. They are waves that are produced as a result of vibrating objects. Look at this object here. It's called a tuning fork. As you see this tuning fork vibrating, you see the wave produced. This wave that is being produced by the tuning fork is what is referred to as sound wave. So, they are produced when vibrating objects are set into vibration. And some of these examples of vibrating objects are talking drum when it is being struck, blowing of flute, shooting of rifle, ringing of telephones. All of these things, when they vibrate, they what generate sound wave. All right. Now, let's talk about how this sound wave is being transmitted. This is a typical way sound wave is being transmitted. Goes back and forth at this what at pressing. Now, these particles are particles of air. Sound cannot travel without the presence of air. So it is present that is what that is the material medium that is required to travel. Now, when a vibrating object vibrates, it sets the particles of air into vibration. And when that happens, there are two categories of there are two parts of the wave that you will observe, sound wave. There's a side that is well concentrated. That side is the compression part of the sound wave. And that's where you hear the louder part of the sound. But the side where you have the lines, the little bits away from each other, that's the air particle now. We call it the rarefaction. That's where you hear the lower part of the sound. But then they are progressing forward. Even though they move back and forth, they are progressing forward. So this is how sound is being transmitted. Once the source vibrates, set the particle into the air particle into vibration, and then they begin to move back and forth. Okay. So if there is no air, there can never be sound wave. Now, when a place where there is no air is referred to as vacuum, sound cannot travel through a vacuum where there is no air. So if you remove air in an environment, you will not hear any sound in that environment, no matter how you vibrate any object. Now let's talk about the characteristics of sound wave. Okay, sound wave has three characteristics, and the first one is the pitch. The pitch of a sound is how shrill or how deep a sound is. Sound is very deep, say that it has a low pitch. If the sound is very shrill or very light, it has a high pitch. Now let's see an example on what this pitch is. Look at this. This is a simulation of sound. Now these are two speakers that are making sound. But let's go to listen to the sound of the speaker. Yes, that's the sound of the speaker. Now I can vary the pitch of the speaker, of the sound of the speaker, either to a low part or to a shrill part. And let's listen to the variation of the pitch. Okay, you will see as I increase this frequency slide there, the pitch goes high, meaning that the pitch becomes very shrill. When I took it downward, it was very deep. That is it. That means pitch of a sound is dependent on the frequency of the sound. The higher the frequency, the lighter the pitch. The lower the frequency, the deeper it. Aside from pitch being the characteristics of sound, another characteristic of sound is called loudness. The loudness of a sound is how high or how low the sound is. Okay, and it depends on amplitude. The higher the amplitude, the higher the loudness. And the lower the amplitude, the lower the loudness. Now let me maintain the frequency of the sound, maybe at this middle here. And now I'm going to vary the amplitude to know the lowness or the highness of the sound. Let's listen. we can say that the amplitude is just like the volume of a sound, how high or how low sound. Alright, so that's all you need to know about the pitch and the loudness of sound. And the third characteristic of sound, which I would like to mention, is the quality of sound. Now look at it. The quality of sound is just the property that makes us to distinguish the same note played by one instrument from the other instrument. A piano will give you a particular note. That same note, if you play it in another instrument like the trumpet, it will sound the same note, but the difference will be there that this is trumpet sound. That's what we call quality. Property that enables to distinguish a note from different instruments. So these are the three characteristics of sound that we have. Okay, so moving on, we are going to be talking about force vibration. What is force vibration? Let's quickly look at this. Let's take a look at this video here. Oh, what force vibration is about. Okay, now let's start. Now look at the man. The object at its right hand side affects the one on its left hand side. Now the left hand side one is the one that is set on force vibration. Now force vibration is just a phenomenon that occurs as a result of a vibrating body causing or influencing the another body to vibrate. A body undergoing vibration under the influence of a vibrating body, same natural frequency as that of the influencing body. That's what we call force vibration. So the one on its left hand side undergo force vibration because the vibrating object on the right hand side are the one that influence the one on the left. Now, resonance is now a special case whereby a point we reach where the one on the left hand side of this man will keep vibrating even when the one on the right hand side stops vibrating. That point we say that it is at resonance. So it's a special case of force vibration which occurs when the system is meant to vibrate at its own natural frequency as a result of force vibration received from another source of the same frequency. So that is just the concept of force vibration and resonance. Okay, having known that, let's go into musical instrument. Okay, when sound wave or when sound is pleasant to our ear, we call it music. But when it is unpleasant to our ear, we call it noise. But they are all sound wave. Now, the instruments that give us music are called instruments, and they are categorized into three parts. The first part is known as the wind instrument. All wind instruments also resonate the air in their column to give sound. Such example of such instruments are the flute. You have to blow wind into it for it to give you sound. Blowing wind into it, resonate or vibrate the air in that in the column of the flute for us to hear the sound. Aside from flute, we have trumpet, we have saxophone, and we have clarinet. Another category of musical instrument is a stringed instrument. These are the instruments that make use of string to produce their sound. But before they can produce their sound, the string has to be plugged. You plug the string like the guitar. When you plug the guitar string, the string begins to vibrate and the vibration gives us sound. Okay, we also have the violin in this category. And then the third category of musical instrument is the percussion instrument, which require that you hit them or strike them for them to vibrate. And such instruments are the drums, the bells, and the talking drum. These are the three categories of musical instruments that we have that gives us pleasant sound. Okay, now let's go into another part of sound, which is called echo. We often use this word echo, and that is when we make a sound and we could hear ourselves again, we say that's an echo. So that is just the definition of echo, is the repetition of sound caused by the reflection of sound wave from the surface. What happens is that when you make a sound that is echoing, it means that the sound wave coming from you goes and hit a hard surface like the wall and then bounces back, which is called reflection, reflect back, you could hear yourself. Now these echoes can be applied in the development of sonar, speed traps, and also in determining speed of sound. Now to determine speed of sound, a formula like 2x equals vt has been adopted, where the x there represents the distance covered by the sound wave, the v is the velocity of the sound, and the t is the time taken over the to echo. Okay, so this formula is very key in solving problems. Now let's go straight to vibration in strings. Vibration in string. We have categorized musical instruments into three, and we have one of them to be string instrument. Now we are interested in the vibration that occur in the string. Now let us dive into our interest. Okay, I would like to show us a simulation of a vibrating string that is on there. Okay, let's do this. Now this is string. Let me set into vibration. So we see this string vibrating. This other side, this end here is fixed, while the other side. Now this string is vibrating. Let me take it slowly. Now you can see. Now when it's vibrating, our interest is the first sound that it makes. First sound that it makes during its vibration. Our interest. Okay. First sound that it makes. And that first sound that it makes, the lowest sound that it makes is called the fundamental frequency or the first harmonics. Now if I pause this vibration now, look at the way that is generated. Pause. Okay. Now the first curve here, represented here, side here, this side. Now if you check here, check us now this is the first part from this vibration. Vibrating, first sound it makes. The second sound it makes obtained with this one here, this one, and then the third sound it makes represented with this wave. Okay, now the first one I said before is fundamental frequency of first harmonics. The second one is second harmonics. But the second harmonics is start the first overtone. But that's the first time it will be. It will the first time it will make a tone that is louder than the first one. Okay, and this third harmonics is called the second overtone. Alright, now for the first harmonics, which is the fundamental frequency, this formula here have been experimentally proven to be the formula. That is F0, which is the fundamental frequency, equals V over 2L, where the V is the speed of the sound and the L is the distance covered by the sound. Okay. Alright, so that's the formula for fundamental frequency or vibration in a string. So moving on, we want to consider certain things here now. For the second harmonics, which is the first overtone, it has been verified that the frequency for the second harmonic, which is F1, is equal to 2 times the fundamental frequency. So this also have been proven to be true experimentally. This version here has been proven to be true experimentally. Okay, that the second harmonic, which is the first overtone, is equal to 2 times fundamental, and then the third harmonic, which is the second overtone, is equal to 3 times fundamental frequency. And so we can say that in a string, the harmonic present are 2F0, 3F0, 4F0, and so on and so forth. In other words, both odd and even harmonics are present as overtones. So for vibration in string, we could say that each of the harmonics are both odd and even numbers. First harmonic is the F0, second harmonic is 2 F naught, third harmonics is 3 F naught, and so forth, and so on and so forth. Okay, so it's very key that we know this. Okay, so moving on to the next one. Vibration produced in open pipe. In open pipes, we also have the same vibration that occur in a string. So the fundamental frequency still remain the same formula. So for vibration in open pipe, it has the same formula for vibration in string. So the fundamental frequency is V over 2L, just like the string. Then the second harmonics is still 2 F naught. Third harmonics 3 F. Okay. So we can say again that in an open pipe, the harmonics present are both odd and even and harmonic. Alright. So moving on now, let's talk about vibration produced in closed pipe. For closed pipe, there's a little different. Okay. In open pipe, the two ends of the pipe are open, both here and here. Okay. But for closed pipe now, only one end of the pipe is open, the other side is closed. That's what we call closed pipe. And now, by experiment, it has been proven that in a closed pipe, the fundamental frequency with the first harmonic, it is V over 4L. Unlike for open pipe where it is V over 2L. So for closed pipe, fundamental frequency is V over 4L. Excuse me, V over 4L. And then for the second harmonics, it is 3 F naught. Unlike for second harmonics open pipe, it is 2 F naught. You see. Now for third harmonics in closed pipe, the frequency is 5 F naught. So for closed pipe, the harmonics are all odd numbers. The first harmonic is F naught, second harmonic is 3 F naught, third harmonic is 5 F naught. So they are all odd numbers. And so these are just the things we needed to see in this topic called sound wave. So till I come your way again, thank you for listening. Bye for now.